Well, so hello guys, here Mr. G with another video about acid and bases. Last time we spoke about acid-base reaction. We looked at many examples and we saw that the salt that is formed is going to depend not only on the acid but on the base as well, because of the positive ion coming from the base as the negative ion coming from the acid. So you could, and this one is a recalling, if you use hydrochloric acid, the salt will be a chloride. If you use sulfuric acid, the salt will be sulfate. If you use nitric acid, it's nitrate. And then ethanoic acid will give you acetate. And then we saw different examples with the salt and the formation with the ions. So all that was done in the last videos related to acid and bases. Today we're going to be talking about salt hydrolysis. Now, by definition, what is hydrolysis? Hydrolysis is the reaction of salt with water. That is what hydrolysis is. What salt are we talking about? Well, the salts we prepared previously in the neutralization or acid-base reaction. That is what we are talking about. Now, this salt that forms can have, or can it form in two different ways. One of them, it can be remaining in the solution, or in other words, be an aqueous solution. There we go. Right? But it could also form a precipitate. Remember, a precipitate is a solid in the reaction between different solutions. Now, what else can happen to that salt? Okay? That salt can now, or it can dissociate completely or dissociate partially. It means that salt is going to be broken into ions. All right? Remember when we spoke about dissociation, for example, the word dissociation is when we have a salt like sodium chloride, NaCl, and this one is going to dissociate. It's broken into Na plus and a Cl minus. This is called dissociation. Okay, that is the name of that one. It's when the salt breaks into ion. So this salt that we're speaking about in the acid-base reaction can dissociate completely or it can dissociate partially. But the ions, it doesn't matter if it's partially or completely, are going to be surrounded by water. So those ions are going to be surrounded by water. Now, very important. Remember we're speaking about the salt. Everything we're speaking here is about what can happen to that salt. And now we're going to a very, very important point here. And we're going back to salt. Okay? Doing it in this way. Those salts have cations and it has anions. Remember, the cations are the positive ions and the anions are the negative ions. Okay? We're speaking about the ions, cations and ions here. Like you see, this one is the cation, that one is the anion. So let's write it here. This one is the cation, so you can remember. This one is the cation, and this one is the anion. Okay, so here we are talking about those. Now, what is going to happen there? The cation can react with water, and if that happens, then H3O plus will form when the cation react with water. And if the anion react with water, then what is going to form is the OH. Okay, so that is very, very important. So far, guys, we're looking here, hydrolysis. What is hydrolysis? What can happen to the salt? We are discussing what happened to the salt. It can dissociate completely or dissociate partially. First of all, we said it can form a precipitate or form a solution, or can be remaining within the solution. It can also, the positive cation will react with water to form hydronium, and the negative ion will react with water to form hydroxide. So just to finish here, what else can that salt do? That can change the pH of the solution when it's go to hydrolysis. So when the salt undergo hydrolysis, And remember, hydrolysis reaction of that salt with water. The reaction can be acidic or can be alkaline. The reaction can be either acidic or alkaline according to that salt, to what happened to that salt, the hydrolysis of the salt. If the reaction is acidic, it's because we have now H3O plus ions extras. We have too much of that ion. And if the reaction is go alkaline, it's because we have too much of the ion OH minus in the reaction. Alright, so this one is the most important thing of this salt. What happened to the hydrolysis of that salt? What could happen? We're going to recall real fast. That salt can remain in the solution as an aqueous salt or can form a precipitate, which is a solid. The salt can dissociate completely or partially. And I show you the example of dissociation. That salt can form cations and anions. You know, when dissociated, form ions which are cations and anions, and they form either H3O plus or OH. And that salt is going to change the pH of the solution, sometimes most of the time. Okay, so now let's want to see that different reaction of the salt with water. Now, before we go to the examples of all the three different possibilities, now, before we go on to the example, this is a very important note. The anions of a strong acid and the cation of a strong bases do not undergo hydrolysis. In other words, the anion of a strong acid and strong bases, the cation of a strong bases, do not react with water. So let's see the very first example of all, and that is a neutral solution. So in this case, we're going to go to strong acid plus strong base. And you need to know that the reaction will give you neutral solution. Neutral solution. All right, the solution is going to be neutral. In other words, the pH is going to be around 7. Okay. Now, for example, let's say we have a strong acid like hydrochloric acid. Okay. HCl, for instance, is in a gas state. It doesn't really matter the state that the hydrochloric acid is. Then it reacts with sodium chloride and HCl liquid, for instance. Now this one is going to be giving you sodium chloride and HCl aqueous, because the sodium chloride is going to be dissolved in the water plus the water. Okay, let's look at this reaction. Now, this is the salt that is formed, and you know that is the salt that formed. Now, that salt dissociates. Note, this dissociation in water is not hydrolysis. Hydrolysis is the reaction with water. Alright, so we have that the sodium chloride now, the NaCl aqueous, is going to dissociate in water. Okay, dissociates in water and it's going to form Na plus aqueous and Cl minus also aqueous. The pH of this solution is going to be 7. It's going to be a neutral solution. Now, because of what we say here, that anions of a strong acid and cation of a strong base do not undergo hydrolysis, it means that these ones are not going to react further with water, so solution stays neutral. The solutions will remain neutral. This is what happens when you have a strong acid and strong base. Remember, This note is very important. Please make sure you take that note. An ion of a strong acid and cation of a strong base do not undergo hydrolysis. This is a strong acid here, and this one is a strong base. Okay, they do not undergo hydrolysis. When I say they, I'm speaking about the ions. Okay, now this is the case of a neutral solution. Let's go and see the case of an alkaline solution, for instance. So let's go a new page here. So let's see here now when we have an alkaline solution. Now this will happen when you have a strong base and a weak acid. The solution will be alkaline. Okay, so that is important to know. Now let's see one example. Let's see, for instance, when a sodium hydroxide, NaOH, reacting with a carbonic acid, or H2CO3. This one is a weak acid. Now in this case, the reaction is going to be given by Na2CO3 plus water. This is the reaction, and then you have to balance the equation. Now, what is happening? This salt here is going to dissociate. Okay, they always dissociate, guys. So now how does it dissociate? Remember, this one is going to be a solid. This one will be a precipitate because it doesn't dissolve in water. Okay, now here, this one dissociates into Na plus. As you can see, the aqueous, because it's going to be in the water, plus CO3 2 minus aqueous. Now, very important, this here, this one there, is a cation of strong base. And I want to go back here, guys. See there? Cation of strong bases do not undergo hydrolysis. So this one here do not go hydrolysis. Not hydrolysis for that anion there. But this one here does go hydrolysis. Okay, it go hydrolysis. Okay, so now the CO3 or 2 minus, this one here, CO3 2 minus, react with water because it does go hydrolysis. Now remember, why this one not going hydrolysis? Because it is a cation of a strong base, and that is the first note I did right here. Now this one, let's write the states, guys. This one is aqueous. It's not very big thing right now, the states, but let's do it. So now this one will react further with water. And how is going to happen? So it will be HCO3 minus, one hydrogen will be transferred from the water to this substance there, aqueous, plus OH, because the water loses one minus. Okay, this one is what happened there. Now the concentration of OH, as you can see here, was increased. You make more OH. Therefore, the pH of the solution will be greater than 7 because of the increase in the OH. This one is quite simple. It's not that bad. And the last one we have, guys, is the acidic solution. Now, the acidic solution, guys, is when we have strong acid plus weak base. The solution will be acidic. Okay, so now let's see one example. The reaction between ammonia, NH3, remember it's a weak acid, and hydrochloric acid, HCl. According to what we learned about acid-base reaction, you should know that the salt that is going to form for this combination is ammonium chloride. Okay, so is ammonium chloride is going to form. Let's go to a new page there. And ammonium chloride, which the formula is NH4, Cl, is going to dissociate in water. Those all always dissociate in water. In this case, it's also going to be a precipitate. Not important right now, but it's going to dissociate in water in this way, so it can form now ions of NH4, which is ammonium, NH4 minus, plus chlorine minus. That is what is, sorry, NH4 plus chlorine minus. That is what is going to form here. Now we go back once more here to the very first red note that I highlighted, and ions of a strong acid do not undergo hydrolysis. So in this case, the chlorine here does not go hydrolysis. Do not go hydrolysis, or in other words, doesn't react with water. But the NH4, this NH4 is going to react with water further. So it's going to be now NH4 plus water, H2O. Guys, you can keep the state. Let's keep the states quickly. We almost done. Plus H2O liquid. All right, and now this one is going to react with water. When this happens, guys, it will form NH3 aqueous solution plus H3O plus solution. In this case, the ammonium will give a proton to the water there. Guys, this one is what happened. You can see that the concentration of the H3O plus increases. There you can see it. You have more of that, and therefore this the pH of this substance will be less than 7, or acidic solution. Guys, this is all about hydrolysis. Quite tricky, because there's a lot here to understand, but it's not a very difficult thing. But thank you for watching, guys. If you think you understand, please thumb up, subscribe for the channel. I'll see you next time. Mr. G here.